Welcome to Summarize Science, where we break down cutting-edge research. Have you ever wondered what stars are made of, or how we know how hot they are from light years away? This paper presents the design and testing of a compact, low-cost instrument that can do just that, bringing the power of astrophysics to students and hobbyists. The researchers set out to build a stellar spectrometer using accessible, off-the-shelf equipment. So, what does it take to build your own star analyzer? The core components are surprisingly simple: a standard reflecting telescope, a monochrome CMOS camera sensor, and a special piece of optics called a diffraction grating. This grating acts like a super-powered prism, splitting the starlight into its full rainbow of colors, or what scientists call a spectrum. To hold it all together in perfect alignment, they designed and 3D-printed a custom mount. But building it is only half the battle. They also needed to make sure its measurements were accurate. To calibrate the device, they first pointed it at a helium lamp in the lab. Since the exact wavelengths of light from helium are known, they could create a precise map matching the pixel positions on their sensor to specific colors. For the final calibration on the telescope, they turned to a famous star, Vega. Vega's spectrum is extremely well studied, making it a perfect standard to fine-tune the instrument's sensitivity. They even developed a custom computer program to process the images, stack them to reduce noise, and extract a clean, final spectrum. And the results are fantastic. The team pointed their spectrometer at a range of bright stars, from hot, blue-white stars like Sirius to the cool red supergiant, Betelgeuse. Just as theory predicts, the spectra were all unique, revealing their light fingerprints. Hot stars showed strong, dark lines where hydrogen gas absorbed light. Cooler stars, like Capella, had many more lines from metallic elements. And the spectrum of Betelgeuse showed broad absorption bands from molecules that can only exist in the coolest stellar atmospheres. Perhaps the most impressive part is how their data stacked up against the pros. They compared their spectrum of Sirius with observations taken by the Hubble Space Telescope. As you can see here, the major features line up remarkably well, which is an incredible achievement for an affordable, student-led project. So, let's recap what this all means. The researchers successfully demonstrated that meaningful stellar spectroscopy can be done with low-cost components and 3D printing. They captured the distinct spectral fingerprints of stars across different classes, proving that their simple instrument works. While it can't compete with massive professional observatories on every detail, this project opens up a universe of possibilities for hands-on learning and research. It provides a practical blueprint for schools, universities, and amateur astronomy clubs to build their own instruments and engage directly with the science of astrophysics. Thanks for watching this episode of Summarize Science.